Again, still in geometry. This is unit 3, 3.1, parallel lines being cut by a transversal. This is video 3 of 4. Before I start this example, if you ever see me starting an example, not a terrible idea to pause the video and see if you can actually handle the example first, and then kind of use my video as more of a check to see if what you did was correct. So inside of this question we have a diagram. We need to find missing variables, and we need to justify our work, and I have stated the most important part. Two lines are being cut by a transversal are parallel. Those two lines are parallel. So I'm going to draw that on the drawing. This question actually can't be handled unless we know that information. So what I want to do is identify what types of angles we see. And if we know what types of angles they are, then we can say a relationship about them, whether they're congruent, whether they're supplementary. So let's look at the angles. I have this angle right here and this angle right here. Notice how those are on alternating sides of the transversal, and they're on the exterior of the parallel lines. So you need to ask yourself what's true about alternate exterior angles. Well, the alternate exterior angle theorem says if two parallel lines are cut by a transversal, then the alternate exterior angles are congruent, which leads me to my equation. 4x minus 15, remember another word for congruent is equals or same, should equal 3x plus 10. And why were we able to say that? Because the alternate exterior angles are congruent. Or again, instead of that word congruent, you may see the word theorem. Just depends on if they're writing the fact that's inside of it or the name of it. Okay, once we have this, we are just simply solving an equation, so we can start to use our reasoning and algebra knowledge, so our justifications that talk about moving things around inside of an equation. So if I was solving, I'd subtract 3x from both sides, so I'd have x minus 15 would be equal to 10, and hopefully when you hear me say subtract from both sides of an equation, that is the subtraction property of equality. Then I still want to solve for x, so I'm going to take that value of 15, I'm going to add it to both sides, and I'm going to write the result. So 10 plus 15 would be 25. And what did I just do? I added something to both sides of the equation. So that would be the addition property of equality. And for those of you folks that are still struggling with justifying things, again, remember that this is like an if. So if I have an equation, then I can add 15 to both sides and write the result. That's what the addition property of equality says. And lastly, it's always a good idea once you find your variable, because we now know that x is 25, not a terrible idea to check your work. So I'm going to plug 25 into 4x minus 15. So 4 times 25, 100. 100 minus 15 would be 85. So I'm really just checking to see that 3x plus 10 really does equal 85. So 3 times 25 minus 15, plus 10 is what the expression says. So 3 times 25 is 75. 75 plus 10, again, gives me 80. So at the heart of the question, if you can recognize what types of angles you have and what's true about them, that'll lead you to an equation which will allow you to solve for your missing variable.